Hi everybody, so this is Bite Size Chemistry Part 2 for Organic Synthesis, and we're going to look at 2014 reaction scheme here. So starting off, we're asked to give a major use for compound Z. So compound Z is a carboxylic acid. Now it doesn't state what carboxylic acid it is, so you have to figure that out. So let's have a look at the top here. There must be some clue. Study the reaction scheme below and answer the questions that follow with reference to compounds X, Y and Z, each of which has 2 carbon atoms in its molecules. Grant. Okay, so we now know that that carboxylic acid is actually going to be called ethanoic acid. So for ethanoic acid, it brings us back to vinegar. Always vinegar. Okay, so ethanoic acid is vinegar. Okay, and you could say food flavouring or a solvent or any of those. Okay, but that's the one I picked there. Okay, part 2. Draw the structure of aldehyde Y showing the bonding between the atoms. Okay, so that's grand. So we just draw in our 2 carbon atoms. We know the functional group is at the very end. So I do my CHO there. And like I have the CHO over here as an angle, as you can see there. Like that doesn't matter if you have an angle or if you have a straight line or not. Okay, it's completely up to yourselves. Okay, which way you have it. Okay, so don't worry about not having it in an angle. You'll see in exam papers, they don't always put it in an angle. So look, that's drawing the structure of compound of the aldehyde Y. Fine. Okay, and part 3 there states to draw the structural formula of the ester formed from compounds X and Z and identify any carbon atom in the ester as a planar geometry. So there's quite a lot going on there. Okay, now I'm going to do this one, even though I said I'll leave esters off to the very end, but look, we'll have a look at it, this one here. There will be a separate video on esters as well. So draw the ester. So first off, we have to ask ourselves, what are the aldehyde, what is the alcohol and carboxylic acid involved? Okay, so the alcohol is going to be your ethanol. So this is this here. Plus, and it's carboxylic acid, so it's going to be C-COOH. And it's going to get you something. Now, remember, for the esters, the number of carbon atoms never change. So just throw in all the carbon atoms there. We have 1, 2 carbon atoms there. Okay, coming from this one over here. Or this one over here, doesn't really matter. You know the ester is going to be there somewhere, so one of those has to have an oxygen, and O oxygen over here. And now we put in our 2 other carbon atoms. Now, I got that one very fast. Okay, simply because, and this is the easiest one to do for all the esters, because you don't need to worry about the number of carbons on either side. Simply because there's 2 on either. You have ethanol and ethanoic acid, so therefore there's going to be 2 carbon atoms either side of the oxygen in the middle. Okay, so I'm just going to leave it at that. Okay, in terms of how you get from this to this. Okay, there will be a video later on going into more detail on where each part is going and so forth. Now, you're also asked to identify any carbon atom in the ester that has planar geometry. Now, before we get into that, let's just name it. You're not actually asked to name it, but I'm going to name it anyhow just for practice. This side, I always, when I'm naming it, I just, wherever the oxygen is here, I just cut it in half, like so. Okay, and then I say the side without any oxygens. Okay, that's going to be the alkyl side. So in this case here, it's going to be ethyl, because there are 2 carbons on this side. So this is the side without any oxygens. And the side with the oxygens, that's going to be the O8 side. So O for O8, oxygen for O8. Okay, there's 2 carbons, so it's going to be ethyl, ethanoate. Ethanoate. Again, I'll go into more detail on that at a later stage in a different video. But you can just look up the Konica flask on esters in types of reactions, and it comes up there too. So, oh yes, planar or tetrahedral. So in this case here, identify any carbon atom in the ester has a planar geometry. Well, the only thing that's going to have planar geometry is going to be one that has a double bond in it, or a triple bond. Now esters don't have triple bonds, so therefore it's going to be a double bond. So this is my carbon atom here. That is planar. And all I'm going to do there is I'm going to just draw a line up to it and say planar. And I'm done. Okay, next one, IV. IV is asking you, how could aldehyde Y be reduced to alcohol X? Well, it's always the same for these. Okay, for any reduction reactions, it's going to be hydrogen with a nickel catalyst. That's this. So hydrogen and a nickel catalyst, also known as H2/Ni. Okay, that's how you do any reduction reactions. And there's actually 6 marks coming for that, so it's quite a lot. So look, we have, if we're going through it there, we have II, part 3, and IV done as well. Okay, not the most challenging of ones, but again, I'm cutting out bits and only focusing on the reaction schemes. So let's go on to the next one. Next one is 2013. Oh yeah. Okay, so for 2013 there, you're asked to study the reaction scheme over here. Okay, ethane and ethyne belong to homologous series. Probably you have to underline or explain the underlined term. Okay, we'll ignore that part of it. Okay, first off, what type of reaction was involved in conversion X? So this is X over here. So again, whenever you ask for these guys, okay, and especially when you're dealing with ethane, and ethyne, all those, ask yourself this: is there more atoms on the left hand side or the right hand side? So we're going from here to here. So we have 1, 2, and plus 2 plus 4 here. There's 6 atoms in total on this side over here. And then if we go over to this one over here, we're dealing with 8 atoms. So therefore, it has to be an addition reaction. Okay, don't overcomplicate those. Okay, so that one's just going to be addition. Okay, you don't even need to say why. What type of reaction and how does geometry change? Well, if you're talking about how does geometry change, draw it out. Okay, even if it's fairly obvious. So look, we're going from C2H4, so that's obviously going to be our ketone, says I. That obviously has to be our alkene. And again, you can draw these hydrogens at an angle if you want. It doesn't actually matter. That's an awful looking arrow there. Let's fix that. A little bit better. And C2H6, and if you draw that out, you have to get an alkane. So we're going from something that, and again, if you're looking for a change, you must put before and after. So we're going from a planar, because there's a double bond present, to tetrahedral. So that's what you have to state in the, how do I get rid of that? There we go. Planar to tetrahedral. You must state the before and after. Okay, that's really, really important. Okay, for B, so let's answer that. Identify the reagent required to bring about, and there are certain conversions present here. So B, I, and I, and part 3. So let's have a go, guys. Let's look at BI. So this is for Y. So Y, if we're looking at it, is over here, everybody. Okay. So we already said it already that this guy over here was ethane. And if we're going onto it, there's a chlorine added onto it, so it's going to be chloroethane. And again, you can draw it out if you want to double check that it is an alkane. Okay, in this case, a chloroalkane. So what do we have to do? So you have to think back to your mechanisms. There is one mechanism there that involved, and again, you'd have to look at it if it's an addition or substitution mechanism. So we have C2H6 here, so 8 atoms here. If we count up over here, we'll have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 on either side here. So therefore it has to be a substitution mechanism. So go back to your substitution mechanism there and ask yourself there, what did you have to do to add on to get chlorine onto it? Okay, and if you think back at your substitution mechanism, you always have the same reactants for it. You need ultraviolet light, which is your condition, and you need, for the reagent, you need chlorine, Cl2. Okay, so we write down Cl2. Has to be Cl2. If you wrote down chlorine as in Cl, it's actually wrong, because you didn't use Cl, the element, you used the molecule. So look, we have Y done. Let's look at Z. So Z is over here. And we said already that this guy over here is ethene. And again, if we count them up, we have 1, 2, 3, 4, 5, 6. And we had 8 over here. So going from here to here is an addition. And then again, you have to go back to your mechanism there for your addition mechanisms. Okay, you had your ethene there. Okay, you needed it to be ethene. And what did you have to do to get an extra few, what's the word I'm looking for? An extra few atoms. Well, ask yourself over here. If chlorine is present here, fine. It's not present over here. It's addition. So what else has been added on? Over here we have 1, 2, 3, 4, 5 hydrogens. Over here we have 4 hydrogens. So therefore we're adding on HCl. Okay? And that's called hydrogen chloride. Okay, not hydrochloric acid. Just stick with HCl, it might be easier for yourselves. So for addition reactions or mechanisms, okay, you're just simply going to say what the difference is between the two, and that's what's going to go down over here. It's only for the substitution ones, from ethane to chloroethane and so forth, they have to be a little bit more careful with. Now, let's look at W. Where is W? Oh yeah, here it is, yeah. So for W here, we're going from, again, we have 6 atoms over here. Let's count up the atoms over here. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's an addition. So we literally just have to get the difference between the two of them. Okay, and again, if you look at it, you'll see that there's 2 chlorines here that is not up over here. So 2 chlorines are obviously going to be our addition. So it's going to be Cl2 over here. That's it. And that's all for that. Okay. Again, they're easy to overcomplicate, but again, if you just look at them logically, you'll be okay. Addition ones are fine, and same for elimination, because you're literally just getting the difference between the two of them. That's it. It's the substitution ones that you need to pay a little bit more attention to. Okay. D. Draw a structure A and give its name. So where is A? Ah yeah, A is over here. Okay. So A is, we have to give its name. Now that could be tricky enough. So I'd recommend for when you're doing this part over here for part D, that what's the word I'm looking for, that we take it step by step. Okay, so we're losing HCl over here for A, and then it goes on to be a polymerization. Okay, so let's have a look at it. This is D now. Let's draw out the original one there. And the original one was CH2Cl. Cl, CH2. Next was CH2Cl. Okay. Now, over here we're minusing HCl. It doesn't matter where you remove the hydrogens here, or the chlorine, which chlorine, okay? So I'm just going to do it out, get rid of the first one over here. So this one is gone now, that's fine. And there's a chlorine is still here, and hydrogen is still here and here. Okay, and we got rid of one other hydrogen. Okay, so let's just leave it at this for a second and have a look at it. Okay, first off, we can see straight away that not each carbon has 4 bonds. This one over here has 4 bonds, this one over here only has 2, so it's no good. Okay, so this format is no good. Now, even if I moved things around, so even if I put this hydrogen over here, and I'll just do it there now, for the sake of it. Say I put this hydrogen over here now, that's perfectly fine to do. Okay, so now I got rid of this chlorine over here, and this hydrogen over here. Let's count them up. This carbon atom has 3 bonds, this carbon atom here has 3 bonds. So we have a problem straight away, in that no matter what way we rearrange things, and you can keep trying, you're still always going to have the carbons not having 4 bonds each. So therefore we must think, perhaps there's a double bond in it, and you won't be told this, you just have to make the assumption yourself. So let's just put a double bond in there, because each carbon atom has to have 4 bonds. So if we're looking at it now, we have 1, 2, 3, 4, over here we have 1, 2, 3, 4. So that's actually balanced. Okay, so we have the drawing of it done now. Okay, so there had to be chlorine moved over here and hydrogen moved from the other one to get it balanced and give its name. Okay, so how do we name this? Well, we've seen it already, okay, in which that is just going to be chloroethene. So chloro, coming from the chlorine present. Ooh. Chloro, and because it's ethene, there's 2 carbons and there's a double bond, that's all you have to write. Chloroethene. And that's the name of it. For D. Okay, and then E. Draw the structure of 2 repeating units of PVC. Again, this is just something you learn off. Comes up quite regularly enough, so it's not a difficult one. So let's just draw it out there. So 2 repeating units of these. It's simply going to be like this. So drawing a carbon, so 4 bonds in total. Okay, because there's 2 sets of it. You could do more than 2, but you draw a minimum of 2. Put our hydrogen over here, and we'll put our hydrogen here, and then over here we have our chlorine, hydrogen here, 2 hydrogens, and then again over here we have our chlorine and hydrogen, and we just draw an extra long bond like that, because we know it's going to continue on. It's PVC, there's loads of these. So all I did there was, this is PVC, was divided up, okay, here and here. Okay, so polyvinyl chloride is what PVC stands for, and it comes from this guy over here. Have I anything else to say on that? Not really. To be honest, that's all that can really be asked for this. You could be asked the mechanism as well, which I do go into some detail in types of reactions in organic chemistry and the conical flask. Okay, so look, we've finished with 2013 there. Let's soldier on to the next one, which is 2012. Oh yeah, I have it here. Okay, and let's start off with A. So A, give the IUPAC names there for the alcohol A and the ester B. Okay, we have to be careful straight away when it comes to esters, just because they can be a little bit tricky. But the A for the alcohol should be okay. So let's go over here to A. Alcohol A, and then propanone there. Now, this is a tricky enough one, okay, just to be careful here. Okay, pro means there's going to be 3 carbon atoms in the alcohol A. That's grand. I actually might just draw it for the sake of it, okay, for now. You don't have to, but I'm just going to draw it to show you. Now, you have to ask yourself there if it's going to be a primary alcohol or a secondary alcohol. Now, the key being coming from a ketone. Ketones always are derived from secondary alcohols. So therefore, the alcohol A has to be a secondary alcohol. That means the OH group goes in the middle here. And you put in the hydrogens for the rest of it. Okay, so if we're naming it, and I'm going to get rid of it now, it's going to be propan 2-ol. You have to put in propan 2-ol. Okay, and that's for part I. I should just move that out a bit there. And then for part I, we're dealing with an ester. And again, these could be a little bit tricky if not done right. So an ester always requires an alcohol and a carboxylic acid. Okay, so ester is B here. So there's our alcohol, and there's our carboxylic acid. So we have to name it here. Well, rather than doing out the structure of it, and again, I'm going to be doing that in a video later on, just go to the methanoic acid there. The methanoic acid contains the oic, meaning O8. Okay, that's the way I think of it. Oic acid, O8. So therefore, that's going to be the O8 side, and this here is going to be the alkyl side. So if we're naming it, it's going to be propyl coming from the alcohol side, and there's 3 carbons, and then over this side here it's going to be metanoate. So that's just a quick way of figuring out what the name is going to be, and just a reminder there that the O8 here, like oic acid, that's the O8 side, and then the alkyl side then is going to be the alcohol. So alkyl for alcohol, oic acid for O8. Just like to know, easy way to remember which is which. So look, that was A and B there, not the easiest, certainly. So let's look at B. Sorry, not A and B, that was A are I and II. B, alcohol A and propan 1-al structural isomers. Explain the underlying term. We're not going to do that now, okay? What structural isomers are. Just say what it is. It's isomers with the same compounds with the same molecular formula but different structural formula. That's all you have to say. Same molecular formula, different structural formulas, compounds. Okay, what's the structural difference between primary alcohol and a secondary alcohol? Well, you just need to define both of these, okay? And again, I'm just going to call it out here because we're not focusing too much on definitions. And students make this mistake all the time between primary and secondary alcohols. A primary alcohol is where the OH group, the functional group, it is the carbon attached to. Sorry, I'll repeat it again. A primary alcohol is where the carbon attached to the functional group, okay, is attached to at least one other carbon. Okay, it's attached to one other carbon, primary being 1. Okay, a secondary alcohol is where the carbon attached to the OH group is attached to 2 other carbon atoms. And again, if you draw it out, you'll see it fairly handy enough. And again, I do explain it fairly well, a lot slower as well in the conical flask under families of organic compounds. So identify another pair of structural isomers. This is one I wanted to do from the reaction scheme here. So identify another pair. So we already have one pair there. So alcohol A and propan 1-al. There are one pair, structural isomers. Well, the next pair, and it's always the same for these. Okay, so go to the aldehydes and ketones. They're the next pair. Okay, so if we're looking at it here, we have propanone over here, and we have propanal over here. And if you draw out both of those, you'll see that both of them have the same number of carbons and hydrogens and oxygens, but different, drawn differently. So aldehydes can be, aldehydes and ketones are structural isomers of one another. So propanone and propanal. You just need to write that down. You don't need to draw them out. Okay, so these two alcohol A and this alcohol over here is an isomer of one another, and because we've got a primary alcohol and a secondary alcohol, and propanone and propanal are also esters. Are also isomers. I saw ester there. Are also isomers. Okay, so identify another pair of structural isomers from the reaction scheme there, and that is propanone and propanal. And that will always be the case, providing that there's the same number of carbons. So like, it couldn't be between ethanol and propanone, for instance, okay, because obviously they contain a different number of carbons, okay. So C, identify a compound scheme where all the carbons atoms are in a tetrahedral geometry. Now, this is an easy enough one to do. Anything with a double bond in it is eliminated all the way, straight away I should say. So propanone is eliminated, propanal, esters, propanoic acid, methanoic acids is also eliminated. So identify a compound in the scheme there. Well, there's 2 compounds that you could have said. You could have said alcohol A or propan 1-al. So either of those 2 would have been fine. Now we know alcohol A to be propan 2-al, so I'll just write down propan 2-al there. So propan 2-al or propanal. You could put the propan 1-al in there if you want, but it's automatically assumed that it's a primary alcohol if you don't have it in. D. Named reagent and catalyst used to bring around the conversions labelled OR. Well, if you're using a reagent and a catalyst, it must be some form of reduction, or standing for reduction here, I suppose. So for reduction, it's always the same, and again, you have to identify which is which. Okay, so it's going to be hydrogen equals to reagent and then nickel equals catalyst. And that's it. Okay. And again, you have to state which is which. Okay, that's really, really important. And if you're not sure, just do it anyhow. Okay, you won't lose marks for us. Okay, propanal is oxidized by Fehling's reagent. Describe how this reaction is carried out and why does propanol not react with it. Okay, let's get started off. So for Fehling's there's a couple of different reactions that you need to know for this. Okay, all you have to say for this, okay, is again Fehling's, and you can see this on the Fehling's A and Fehling's B. You can see this on my website there for what am I looking for the experiment section. It writes this up easy enough in a test tube. Okay, plus your aldehyde plus heat. I'll just do it over here. Plus heat. Okay, and if you do that out, okay, what should happen there is you should get a blue to red color. Okay, gives us blue to red. Now the red is actually precipitate. Okay, so we should really put the precipitate in PPT. Okay, so I'll repeat it again. For the Fehling's, okay, I forgot to write down Fehling's B up here. Fehling's A and Fehling's B in a test tube, plus your aldehyde, you heat it and you get a blue to a red precipitate, okay? Now, if you put a ketone inside there, so again it could have been, I think they said propanone. Why does propanone not react with it? Okay, and again, there's under the same one there. If you put propanone here instead, okay, you'll get no red precipitate. Okay, propanone is a ketone. A ketone, which is very difficult to oxidize. Difficult to oxidize. That's all you have to say. So therefore, our Fehling's A and B are oxidizing agents. Okay, they'll work for aldehydes. They'll work for because you're going from an aldehyde just to a carboxylic acid. Okay, but they won't work for ketones. Next, F. Which compound in the reaction scheme would you expect to have a fruity odor? Okay, as soon as you see the word fruity, okay, it's going to be esters. So ester, we've named it already. Ester B is going to be propyl metanoate for that one there. Okay, look, I'll write it down just to keep everything consistent. So that's F. So propyl metanoate. And again, if you just wanted to say, if you just wanted to say ester B, you would have got full marks. So look, guys, that's it for this one. Okay, I'm going to do the next one now. On these, I'm going to do a few more questions. So it's 2012 we did there, and 2013. I can't remember or not if we did 2014. I don't think we did. But so that's 2013 and 2012 there anyhow. Done and dusted. Okay, everybody, look, I hope you took something from that, and I'll be doing another one in the next few days.